In this video, I wanted to work through with you some popular review problems from our logic module. Let's get started. Suppose you have a statement and we ask you to write the negation of the statement. And the statement is one in which we had a qualifier word like no one. How would I negate that statement? No one passed the test. Would I need to say that everyone passed the test? That's a very common mistake. No, in fact, remember the negation of no one or none is that someone or some did, okay? So as long as someone passed the test, then this would be a negation. It's basically saying that the original statement was not true. So someone passed the test would be a nice negation of the original, okay? So again, you don't have to overdo it. You don't need to say everybody passed the test. That's not needed. All you need to show is that at least one person passed the test when someone makes a sweeping generalization like no one. Okay, let's head over to our next common problem that students struggle with. Translating back and forth can be confusing for many students. So if you're given a statement in logical symbols, are you able to rewrite it as an English sentence in a way that kind of makes sense, right? So the original symbolic statement here is parentheses, Q and R, close parentheses, then P. So if Q and R happen at the same time, then P must follow. That's what this conditional statement is reading. So assuming that P is known to be the coffee is good, Q, the coffee is hot, R, the coffee is strong, then how would I rewrite this statement in English? So go ahead and take a moment and try it yourself. See how you do. Okay, so you would say if the coffee is hot and strong, you don't need to say and the coffee is strong unless you really want to write extra. And then notice what I'm going to put here. I'm going to put a comma after that because that comma is telling me that those two things were grouped together, okay? The Q and the R were one thought. They're my antecedent, if you will. So if the coffee is, I need to put my verb here. If the coffee is hot and strong, then it must be good. Now, I added the word must to make it sound better, but you could just say it is good, right? Okay. So that is what this is saying, right? Then P should follow. Then it must be good. It should be good. Okay. So that would be one way that I could rewrite a symbolic logical statement, in this case an if-then statement, as an English sentence. But notice what was really important was recognizing the grouping so that the antecedent and the consequent are separated, and the comma helps us to do that. And order is very important. Okay, let's try another one that's common. How about going the other way, right? Using the same P, Q, and R from our previous example, could you rewrite this statement symbolically? So take a moment and see if you can go back and write this symbolically. What does it say here? It says the coffee is good if and only if the coffee is hot. And then there's a comma, and the coffee is strong. Okay, so that's telling us something, that everything before that comma is together, right? So I'm going to put parentheses because of that comma there. And then I'm going to put the and because of this connective. Okay, now going back to my previous slide here, this is question 3. So in my previous slide, the coffee is strong, I believe was letter R, right? That was letter R. The coffee is good, I believe was letter P. The coffee is hot, I believe was letter Q. If I'm wrong, then forgive me, okay? So how do I put those together with an if and only if? Do you remember which connective that was? That's right, it was our double arrow. So we're going to do a double arrow here, P, double arrow, Q. That's saying P happens if and only if Q happens. So if one happens, the other happens. If one doesn't happen, the other does not happen. They have the same truth values at all times. So those two are connected in that way. And by the way, R happens. Coffee is also strong, okay? This would be how we would write this symbolically. Now you might be wondering, did I have to put those parentheses there? Yes. If you did not put those parentheses there, you would be saying P happens if and only if Q and R happen, okay? So that's a very different statement. So that comma was very vital to tell you who was grouped together. All right, let's see another common example students struggle with. What about determining the truth value of a statement? So the truth value is not about an argument, which is valid or invalid. This is about a statement, whether it's true or false. Now, you may not have done a lot of practice with this because we often assume statements to be true, especially when we're dealing with arguments, right? But if someone just gives you an English statement and they say, hey, is this statement true or false? You may be able to tell, not even needing a truth table, just based upon the facts of the matter. So let's take a look at what we have here and your basic understanding of logic. It says Valentine's Day is in February. Okay, so that's a nice simple statement. I'm going to call that statement P if you don't mind. It has a comma there, so that's one idea. Or Christmas is in December and Easter is in May. All right. So assuming that we're talking about the traditional US version of holidays, Christmas is typically celebrated in December here, so we would say that could be statement Q, and that would be a truth. Valentine's Day is typically celebrated in February here, so that would be a truth. That's statement P. And Easter is in May. Typically in the US, that's not the case. It's a little later than it usually falls. So that would be a falsehood, and this would be like statement R. Okay. So what you could have done is you could have written this symbolically as P or, so that's the or symbol that we see here. Q, Christmas is in December. Okay. But notice it's telling us with this comma that everything after the comma is together. So I need to put everything after the comma in parentheses, right? Q and, that's what this symbol says here, and Easter is in May, R. Okay. So then if you knew when one of these is true and one of these is false, you could answer this question really easily. There's one falsehood here, and we said it was Easter being in May, right? That was the falsehood, letter R. So this one right here is actually false, and it's paired up with a truth, because we said that Q, Christmas is in December, is a truth. That's a truth. And then we have our or statement, and P, Valentine's Day in February, that was also a truth. Okay. So what we want to do is work our way from the inside out, right? There are no negations to do here. So we simply look first in the parentheses. Let's go there first. True and false. When is an and statement true? When they're both true. So that means that this entire thing here turns out to be what? False. The only time that this would be a truth for an and is if they're both true. So that's a false. Since there's no longer two things but just one, I can get rid of the parentheses. So now I have T or F. Now this is an or statement. I just brought my T down. Now this is an or statement. When is an or statement true? That's right, if at least one of them is true. So this is in fact a true statement. Okay, now could we have known that without doing all of the symbols? Perhaps, if you're really paying attention. Valentine's Day is in February, that's true. Or Christmas is in December and Easter is in May. Well, we know the second part of after the or has to be false because not both of those things are happening, right? So then we have a true or a false. Since one of them is true, the or statement is satisfied. So you might have been able to work it out in your head, but I highly recommend you go through the process of writing your steps out with logical symbols so that you don't forget or get confused. Okay, let's try another popular one that students struggle with. Ooh, equivalent statements. These are probably the hardest thing for most of my students besides truth tables. So writing an equivalent statement of another statement that's already in English, all right? This statement says, it is not true that if you just come to class, then you will pass the class, okay? So let's take a look at how I would write this symbolically. Feel free to pause the video and try it on your own. So not true, that tells me we need to have a negation, right? That if you just come to class, now I notice there's an if here, and there's a then, right? So this is an if then. So what is not true? The following if then statement. So I'm going to put parentheses around it. So what's not true? This if then statement. What is this if then statement? If you come to class, that could be letter P, then you will pass the class. That could be letter Q. Okay. So this is the original statement. They would like us to write an equivalent statement to this. Now, if you look back in your notes from the section on equivalent statements, we had some which were very popular where you can memorize them and not have to reinvent the wheel each time with a truth table, right, to show that something is equivalent or not. This appears to me to be what we called a negation. That's a negation right there. A negation of a conditional statement or the conditional. So if you find that in your notes, go ahead and do that. Pause the video if you haven't already figured that one out. What is that always logically equivalent to? Using symbols here. Did you find it? So it's saying what is this negation meaning? It's really saying this if-then statement is not true. So when was an if-then statement not true? If the first thing was true and the second thing was false. So if P happens and Q does not happen. That was what we called the negation of the conditional. Now, if you wrote that on a test, you're probably not going to get full points, right? Because that's not in English. Someone wants to know in English, how can I say the same thing? So how do I say the same thing as, it is not true that if you just come to class, then you'll pass the class? Well, that would be equivalent to saying P happens and not Q happens. So P was, you come to class, or you just come to class, and that was this connective here. You did not pass the class, or you don't pass the class. Now, some people would say, that sounds kind of clunky. Couldn't I have also said but you don't pass the class, right? And but mean the same thing. So these statements should be what we call logically equivalent. The negation of a conditional is the same as the antecedent happens and the consequent does not follow, okay? So you come to class, but you didn't pass the test, so it wasn't a true if-then statement. Hopefully that makes some sense, but besides this particular example, I would recommend you try this type of problem where you translate from one equivalent statement to another in English with the other ones that we talked about in our notes. So go back to that video or your notes to make sure that you can feel comfortable going back and forth with equivalent statements. Making flashcards or even like a game where you're matching, that might be helpful. Here's another popular one that students sometimes struggle with. Writing the converse, the inverse, and the contrapositive of a conditional statement. So here the original is, if you do not prepare well for a test, then you will not pass the test, okay? So we have an if-then statement, and you could originally write this in symbols, right? Not P, then not Q. That might be an option. But remember what each of these means, okay? The converse and the inverse, remember that those two are not equivalent to the original. So let's talk about the converse first. What did that require us to do? Flip only, right? So if we flip only, we would say, if you did not, I'm going to go past tense if you don't mind. If you did not pass the test, then you did not prepare well for it. That would be the converse. All I've done is I've flipped the original two statements, the antecedent and the consequent. Notice I did not change the original negations that we had. I kept those the same. What about the inverse? What did that require that we do? Do you remember? That's when we negate only. Now this one is kind of confusing for many of my students. Let me see why. Let me show you why. To negate only typically means you're going to see the words not, right, inserted. But what if you already had not and not, right? Well, taking the opposite of a not now makes it a positive, right? So in the original we had, if you do not prepare well for a test, then you will not pass the test. The inverse would say, if you do prepare well for the test, or if you did prepare well for the test, I'll do present tense. If you do prepare well for the test, then you will, not will not, but you will pass it. Okay, so the inverse was only negating each individual antecedent and consequent. It was not flipping, it was only negating. Remember, both of those, neither one are equivalent to the original. They're equivalent to each other, though. So you can make a little note of that. They're always equivalent to each other because they're contrapositives of each other. What about the contrapositive here? How do we find the contrapositive which is equivalent to the original statement? What did the contrapositive require that we do? That's right, flip and negate the original statement, even if it's clunky like this one. So if I flip and negate, that would be if you passed the test, I'm just saying past tense because it makes more sense in English. If you pass the test, then you must have prepared well, or you can just say you prepared well. For it. Okay, so here we've flipped and we've negated. And again, the contrapositive means the same thing. It's equivalent to the original conditional statement. However, the converse and the inverse are not equivalent to the original because they're only flipping or they're only negating. They're not flipping and negating. So make sure you have those ones straight and you understand how to apply them and recognize their usage. Let's go to another one. This one's another really hard one because it's about equivalent statements again. Determine which statements below, if any, are equivalent. And let's try to do this without guessing. Let's use our logical knowledge that we've studied here. Our first statement that we have, let's rewrite it in symbols here. It says, if you jog daily, so jogging daily could be letter P, then you will lose weight. Again, we're not saying this is true or false, so don't get all upset at me. You might jog all the time and don't feel like this is true. We're simply talking about this statement in logical form, which would say, if P, then Q. Okay, so if P, then Q. Well, that's our normal conditional statement, right? Our normal conditional statement. So let's just take a note. That's what we're dealing with. Okay, well, we have studied some ways that we could say the same thing as that, haven't we? For example, the contrapositive where we flip and negate. So for example, if you end up seeing the following, if you did not lose weight, then you must not have jogged daily. That would be the contrapositive. That would say the same thing. And we've also studied in another way using our disjunction. So check back in your notes as to how we did that. Take a look at our second statement here. It says, if you don't jog daily, so that's like the negation of P, then you won't lose weight. That would be like the negation of Q. So this statement in symbols would say, not P, then not Q. Another if-then statement, right? Is that the same as the original in part A? Are A and B equivalent? No. These are what we call inverses. So this is the inverse of the original statement. Those are not equivalent. Okay, so we already know A is not equivalent to B. Okay, so we got that down. Let's take a look at C. Either, that usually means we're going to have an or statement, right? So let's rewrite this as an or statement. Either you did not jog every day, that's going to be negation of P, or else you would have lost weight. That's the negation of Q. So we have negation of P or, oh, not negation, I think I said that wrong. This was just a regular Q. Yes, you would have lost weight is the regular Q. Okay, not P or Q. So for number 7 here, what do we see here? Is that equivalent in part C to any of the above statements? Well, if you look back in your notes, one thing that we've talked about is that you can write a conditional statement as a disjunction. And it was actually just like this. If you have an if P then Q situation, that means the same thing as saying, well, either P did not happen or else Q should have followed, which is not P or Q. So this is in fact equivalent to if P then Q, which means the final answer is that statement A should be equivalent to statement C. Okay, so that took some thinking, right? You might have felt it was right, you might have felt it was wrong, but the answer with this is always do not trust your gut when you're dealing with logical statements and arguments. You need to actually be able to prove that they are true, false, valid, invalid, equivalent, not equivalent, etc. Okay, we got a couple more we're going to look at. If you're ready, let's go to the next slide. Do you feel comfortable we're using a truth table to determine whether statements are equivalent? So in the previous example, we asked that you did so by simply recognizing the forms that we had memorized, right? Which is what we did in the last one. But remember, you can always use a truth table if you forget one of the standard forms. So here we have two compound statements. The first one is parentheses, not Q, then P, so arrow P, close parentheses, and P. So basically this is saying, if Q does not happen, then P follows, and P must happen. The second statement is negation of parentheses, not P, double arrows, that's our biconditional, Q, close parentheses, or P. So that's saying it is not true that not P happens if and only if Q happens, and P must happen. Okay, so in order to do this using a truth table, we first need to recognize that there are only two simple statements, P and Q, even though it looks pretty complicated. So that's kind of good news as far as time is concerned, because we only need to have 4 rows, right? So for the P column, that's true, true, false, false, and then true, false, true, false. And then where do we go from there? Well, to show that two statements are equivalent, they must have the same or identical columns. So they have to have exactly the same truths at the same time and the same falsehoods at the same time. If that doesn't happen, they're not equivalent. So let's take a look here. To build out our first statement here, we need negation of Q. We need a P column, which we have. We need to put them together, so that's negation of Q, then P. And then we would need to put that together with and. So negation of Q, then P, parenthesis, and P. Okay, so let's see if we can build the left statement first. So the negation of the Q column is just taking the opposite of the Q column, so feel free to pause the video if you haven't already tried it on your own. So if you take the opposite of the Q column, instead of TF, TF, did you get FT, FT? I hope so. FT, FT. And then to get the negation of Q, arrow P, remember for an if-then statement, it's only false if the first is true while the second is false. So when not Q is true, so that's our first, and if P is false, make sure you look at the right column, that's our second, okay? Not Q, then P. So does that ever happen? Yeah, it happens in the 4th row. Not Q is true while P is false. So there's our only falsehood. The rest of them appear to be true, 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 false. Okay? Then we need to actually build the entire statement, which includes and P at the end. So we're going to take that previous column we just had, and we're going to put that with the P column from the beginning, and we're connecting these two with and. When is an and statement true? When they're both true. Well, that happens in the first case and in the second row as well, but the last 2 rows it does not happen. Okay, so we're going to hold on. Here is our first statement. Okay, so this is statement 1. Okay, so we're going to see if statement 1 is equivalent to statement 2. Let's build out statement 2 now, shall we? We shall. So for statement 2, we want to have in parentheses, not P if and only if Q. Then we want to take the negation, and then we want to connect it with P using disjunction. So first I need a not P column, which I don't yet have. Then I need a not P if and only if, double arrow, Q column. Then I need to take that and negate it, take the opposite of it. So just rewriting the whole thing there. And finally, I need to put that together with the P as a disjunction. So negation, parentheses, not P if and only if, double arrow Q, close parentheses, or P happens. Okay, kind of clunky. Let's get started with the not P. For the opposite of P, we're going to have FFTT. FFTT. Next up, we want the if and only if. What was required for this if and only if to be true? A biconditional is true if they're the same. That's right. So we're looking at the not P column, which is right here, along with the Q column, which is right there. And we're connecting them with if and only if, which is going to require them to be the same truth or false value. So let's look at the first case here. Not P is false, while Q is true. Those are not the same, so that will be a falsehood there. What about the second row? Not P is a falsehood, Q is a falsehood, so that is a truth because they're both the same. So that's what this requires, them both to be the same. Third row, they're both true, so that would be the same again. But the fourth row, one is true while one is false. So that's a falsehood. So make sure you do that one right because the next one builds on it. Because now we're just taking the opposite of that column. So take the opposite of it. Instead of false, you get true. Instead of true, you get false. So we should have TFFT. TFFT. And finally, we want to combine that with our P column as a disjunction. So we're taking that column we just had together with the P column way out yonder at the very beginning. We're combining these two, and the connective is or. What has to be true for an or statement to be true? At least one of them has to be true. Well, in the first row, that's happening. In the second row, one is true, so that's happening. But in the third row, they're both false, while the fourth row, they're both true. So let me make sure I said that right. No, in the fourth one, they're actually false as well. Yeah, so true and false. So the last two are both falsehoods there. I think I have that right. So T, F, F, T. Okay. If I made an error somewhere, reach out to me because it's been a long truth table. But the basic idea here is we want to see whether or not these are equivalent. And as long as these are not identical at the end, then we can say that these are not equivalent. Okay? So in this case, are they the same? T, T, F, F, T, 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 T? No, they do not appear to be the same, so they would not be equivalent. Okay? So if you can show that they're not the same in the end, statement 1 and statement 2 are not equivalent, we're done. Okay. So those take a lot of time and they can be tedious, especially if you make one little mistake. Again, if I made a mistake, let me know. All right, let's head over to our last example of common problems students struggle with, and that is determining whether or not an argument is valid or invalid using either truth tables or standard forms. So this statement is an all statement. We haven't seen one of these in a while. In a previous video, we might have mentioned one. It says all Floridians live near a beach. Okay, we're assuming that's true even if we know that not to be true. So all Floridians live near a beach. So that's the first premise. Alex lives near a beach. Therefore, Alex must be a Floridian. Okay, so assuming that the premises are true, even though we know in this case they're not, would this have been a valid or invalid argument? All right, well, let's see how we would rewrite an all statement into an if-then statement. So for premise 1, we would say all Floridians live near a beach. Maybe we could write it as, if you're a Floridian, then you live near a beach. Okay, so if that is your original first premise in words as an if-then statement, we could write that symbolically as, I'll use the letter F for Floridian. If you're a Floridian, so F, then you live near a beach. I'll use B. If F, then B, okay? For our second statement, we see it says Alex lives near a beach, okay? So I'm just gonna write B for beach, someone who lives near a beach, okay? The conclusion is that Alex must be a Floridian, so I'm gonna use F for Floridian. Now, if you recognize this as one of our standard forms that are always valid or always invalid, then you're finished, okay? So let's see what we have here. For our first premise, we have an if-then conditional. For our second premise, notice we have the consequent of the first premise. Okay, so that consequent is then it's saying by conclusion, the antecedent should follow. In other words, B implies that F should happen, according to the first premise and the second premise together. Well, that's what we call the converse of the original statement, isn't it? F implies B is the converse of B implies F. So this is actually a fallacy of the converse. So this is an invalid argument. But if you did not recognize it as such, what would you have had to do? You would have to use a truth table where you show that premise 1 and premise 2 together always imply the conclusion. If you can show that this is, in this case, not a tautology, then you would have the same result, an invalid argument. Okay. So again, we can't just decide that an argument is invalid because we don't believe with the premises, because that's not what it's asking. It's asking you, do these premises, assuming they're true, force that conclusion to happen? Okay. So in this case, while it would be an invalid argument, it also would not have been a sound argument, right? Even if this had been valid, it wouldn't have been sound because the premise was false. But assuming it was true, it could be either valid or invalid. All right, well, I hope this is helpful for you as you prepare for your exam on this topic. In general, logic is a very important topic. Argumentation is really important. Can you really reason something and be convincing, not just using emotion, but using facts and logical reasoning? All right? If you have any questions on this stuff, let me know. Otherwise, happy practicing, because math is not a spectator sport. I'll see you next time.